In this segment, we'll look at the monad type class, which is used, among other things, to help us deal with I/O and other kinds of side-effecting computations or general computations in Haskell. When Haskell was first designed, there were a number of competing ways of dealing with I/O, some inherited from other languages, and some new, were prototyped. But the approach that had the most traction was the approach using what are called monads, and that's what we're going to look at here. Now, monads are somewhat controversial. You'll find lots of different videos introducing monads, each one with their own particular approach. And you could say this one is yet another. Some people say they're overly mathematical, others say they're straightforward. What I hope I can do here is give you an explanation that is intuitive and straightforward and allows you to understand what is perhaps a not so familiar, not so comprehensible operation called bind. I'll explain that in terms of something that is a bit more straightforward, a generalized function composition. Okay, but I'm jumping ahead of myself a bit there. Let's get started with the basics. So what is something of type IOA? IO is an instance of the monad type class. It's the instance that allows us to do IO from Haskell. And what it is, it's a type of computations, if you like, it's representations of IO programs. And it's something of type IOA, it's something that does some side effects and yields a result in type A. Now, the types IOA and A are different, they're not the same. Now, elements from A can be used in the IOA world, just a pure integer can be used in a program which does all sorts of side effects and produces an integer, but there isn't a way of converting IOA back to a plain A. But the nice thing is there is a way of sequencing computations that do side effects, and that's the idea behind monads. So the class, the definition of the class of monad, it builds on top of applicative, hence the descriptions of applicative we've had already, descriptions and examples. And there are two operations in monad. One is return, and that takes something of type A to something of type M of A. So it moves something from the pure world into the computational world. In the case of IO, it allows you to use a pure value inside a computation. But we also have this operator bind, which takes something of type M of A and a function from A to M of B and gives us back an M of B. I want to explain a related function called fish and then explain bind in terms of that, because I think that gives a more intuitive explanation than going directly into bind. So let's do that now. So this operator fish, it's a generalized function composition. Here's the type. It takes something from C to M of A and something from A to M of B and gives us something from C to M of B. And you can think of a function C to M of A as being a function from C to A that has side effects. So here I've illustrated that by this function arrow that has this cloud attached to it. Those are the side effects going on when you apply that function. And we can have a similar function that goes from A to M of B. That has side effects. And this operator fish, it's called, it takes the output from this side effecting function and pipes it into the input of the next one. And so putting those two functions together, we get a function from C to M of B. So if we think of a function from something to a monad type M, then these are as a generalized function, then this is the generalized way that we do function composition. So it's composing side effecting functions together using this operator. Now, this operator fish is closely related to this operator bind. And as I've explained, fish is a generalized composition that sequences functions with side effects. Now, bind you can think of in the same way. It's a generalized application that applies a side effecting function to a general side effecting value. And what I'm going to show you now is you can define each of these in terms of the other one. So let's have a look at fish first. Here's a definition of fish using bind. We want to sequence together the functions f and g that have side effects. How do we do that? Well, we return a function that takes x of type C, and what's the result of that? Well, remember f expects a value of type C, so we apply f to x, that gives us something in type M of A, and then we can generalize, we can bind that value and use it in G. And so this bind is like, it takes the result of a side effecting function and passes it into another side effecting function. So here in a straightforward way, we apply f to x, bind that value into G, and then that's the result of our overall function C to M of B. Going in the other direction, suppose we want to define bind in terms of function composition. What we do is we compose a function that has a constant value v. Suppose we've got the value v is type M of A, then we compose G with the constant function that takes a value from the unit type to v. So we compose those two functions together. That gives us a function from the unit type to M of B, and then we apply that whole function to the unit value, and that gives us something in type M of B. So the two are, you can think of fish as a generalized composition and bind as a generalized application. It takes one of these monadic values and allows you to apply a function, a pure function, returning a monadic value, and gives you back a monadic value of the result type of the function. So that explains the functions that are in the monad type class. What we'll do next is look at some instances of that type class beyond just I/O.